Hello, everybody. Well, in this case, we are going to model a geometry uh, machine. And in this case, we're going to take as a reference a rectangular specimen for tension testing of metallic materials based on the ASTM standard E8. And well, in this case, we're going to take as a reference the information that appears here. This is the drawing of the specimen that we are going to model first, and we're going to take the information of this column that refers to a subsized specimen. So we are going to use, in this case, the software Katia. I'm going to open the software. Wait to wait, it is loading. Okay. Uh, well, now that the software is open, and all the time when we open the software appears a product, but in this case we don't need a product. We're going to work with a part. So we need to make click here and close this product, and then we need to open a part design. Um, we need to make click here on start, then mechanical design, and then part design. Enter the part name, part one, doesn't matter. And we need to press on the OK button. Now, as you can see, here we have a part. So I'm going to adapt my material. And here we have the geometry that we are going to take as a reference to model the specimen. So first, what we need to do? First, we need to select the plane, and then we need to make click here over this icon that is called sketch. So apply this, you just need to make a click over the sketch button, and then you're in the two-dimension view. And in this case, first, as you can see here, we have a lot of tools. You can put it wherever you want. Maybe in some cases, the tools are not going to appear in the same positions that appears here. You can adapt it as you desire. But, well, in this case, we need to start with a rectangle, and we need to create a rectangle. What I'm doing, first, I'm taking a rectangle as a reference. I'm going to try to get the same dimensions of this section, that is the grip section. So as you can see here, the dimensions of this rectangle appears here with the letter C, and the dimension of the width is 10 millimeters. Here it is, 10 millimeters, the value of the width of the grip section. So we just need to select the vertical line, and then we need to apply a constraint over it. So to modify the geometry, you just need to make a double click over the dimension, and then we need to type, in this case, 10 millimeters. So that's one of the dimensions. So we need to get the other dimension, and in this case we need to take as a reference the letter B. That is the length of the grip section, and the length of the grip section is 30 millimeters. So I need to tell you something. Maybe in some moment we're going to modify this length because we need to focus on the reduced section of this specimen. That is the most important part on this kind of analysis. So on the tension analysis, so we're going to focus on the reduced section, trying to maintain the dimension that are specified here, and maybe in some moment this dimension is going to be modified. Okay, so that's one part. And then, as you can see, we need to create the other side of this specimen. and trying to have more or less the same dimensions. So look, here is projected a line, a blue line. So that means that if I press here, uh, my I start here my geometry. Look how appears another dotted line on the lower side. That means that this line is a projection of this other one, and this line is a projection of this other one as well. So at this point, maybe I can define the final length of the specimen. That in this case, the final length of these specimens appears here with the letter L, and the dimension is 100. So double click over the constraint and then type 100. There you have. So at this moment, we have the total length of my specimen, and then I need to create these horizontal lines, the horizontal lines of the um, reduced section. So I'm going to use this tool called line, and then I'm going to trace the line. And look, for example, when I have an horizontal position, my line turns to um, blue color. So that means that we are tracing an horizontal line. Then when I'm having contact with a vertical line appears a symbol over on this part, more or less, that is formed by those circles crossed by our horizontal lines. That means that I have contact um, with these two lines, the horizontal line that in this moment I'm creating and the vertical line created before. So, and look, if it is creating a coincidence um, in this moment. So we need to trace another line, another horizontal line. Here we have it. Here we have contact, and that's it. So what's the distance between these two lines? In this case, this is the width of the reduced section, and the width is 6 millimeters, as you can see here over on the on this chart. So we have 6 from this part, from this other part. So we need to type 6 millimeters, and that's it. And remember, we have 10 millimeter to 10 millimeters of the whole length of the specimen. And in order to have centered this geometry, we need to define the distance between this line and this other one. So 10 millimeters minus 6 millimeters between two, we have at the end 2 millimeters. So that means that if we trace here a constraint, um, we need to type here 2 millimeters in order to have centered this reduced section. If you want to check only that that's correct, maybe you can apply this other constraint, but in this case it is not necessary, so you need to apply or to press the escape button. So there you have the geometry, and at this moment everything is okay. So the next point or the next step on the procedure is to create the arcs that we have here on the reduced section. So we're going to trace it. You can do it, these arcs, in different ways, but in this case, we're going to use a 3-point arc. Look how it works, this tool. First, you need to define the starting point of that arc, and we are going to use as a reference the corner of the rectangle. Then is a dotted line. We have here a dotted line, and then we need to press more or less over here the second point, and then we need to trace the whole arc. But and look here, As you can see, it is appearing over my final point of the arc. It is appearing the symbol that we have contact. Remember, we have it disappears on blue color with two formed by two circles and crossed by an horizontal line. In that point, we have contact, but we don't need only contact, we need tangency. And then look, here appears another symbol. These symbols, it is formed by two horizontal lines. Um, and look, in that case, here we have tangency, but not contact, but we need contact plus tangency. The two symbols they need to appear at the same time. Okay, so look, there you have the first one. So we need to define the length of this radius, and look, for example, in this case, the value of the radius is here. We have 6 millimeters. So you need to modify it and press 6 here. 6 millimeters. Okay, there you have the first arc, and we need to repeat the procedure in the other three parts, and the other remaining three parts, on this part, on this other one, and in this one. So that means that we need to use that tool of 3-point arc several times. If you know that you are going to repeat the process, you can make a double click over the tool, a double click. Okay, if you apply a double click, look what is happening now. You can repeat the process, 1 point, 2 point, um, contact plus tangency, and look, we can use again the tool and again. And if you don't want to use it, the tool anymore, you just need to press the escape button on your keyboard, and that's it. Then you can repeat in all the tools that appears here on the sketch section. Then you can do the same. Okay. For example, here I need to create a lot of constraints. In this case, 3 constraints. So I need to. I can make a double click over the tool, and then as you can see, you can create several constraints, and then you don't want to use it anymore. You just need to press escape button over your keyboard, and that's it. Then you just need to modify it with the final value, 6 millimeters, 6 millimeters, and let me check, 6 millimeters, and that's it. At this moment, we almost have the whole geometry, but we need to center the geometry. Okay, first we need to define the length of the reduced section area. In this case is represented by this letter, and the value is 32. So that measure comes from the final point of the arc to the final point of the other arc. So in that case, we need 32, and that's it. 32, and in order to have centered the reduced section, we need to have the same distance on the grip sections. In this case, we have 30, and on the other side, we have 29.056. So 29.056 plus 30 between 2. I'm going to press the escape button, and then I'm going to modify this geometry to 29.4 5 to 8. So that's the final dimension. And just to look if it is correct, look, I'm checking that we have the same value on this side, that we have the same value on the other side. So we're going to press the escape button, and that's it. We have the final dimensions, but at this moment we have here necessary geometry or necessary lines. For example, we need to delete, for example, this vertical line, just applying the delete button over on your keyboard, and then the other vertical line. We need to do the same, just pressing the delete button on your keyboard. And look here, we have a part of this horizontal line that it is not necessary. So how can delete this line that it is not necessary, this part of this line? In this case, we can use here the tool called look quick trim, and remember to make double click over it. So double click, and that's it. How it works, this tool, for example, if you press the geometry, you just need to press the geometry that you want to delete, and this geometry is going to be deleted until the intersection with other line, for example, in this case with this arc. So if you press here the, the, the line, the horizontal line that you don't want, look how it is deleted until the intersection point with other line or other arc. And then you just need to repeat the procedure in all the elements that you need to erase, and that's it. Look, here we have our final geometry, and then we need to get out of this sketch. How we can do that? Just pressing this exit workbench. Then, in order to have a volume on this sketch, we just need to use this tool that's called part, and we need to give it the length of this path. And in this case, this is represented with the letter T, and we have 6 millimeters. Look, 6 millimeters of length. And there you have the final product of the modeling part. And this is the final product as well in the machining process. So for this video, this is it.